Now let's do the fourth problem, second one. Okay, so that is the f of x is equal to this one. Okay, let it be f of x. Okay, it's okay. Okay, this is the we have find the derivative of this using first principle of derivative. Okay, FPD. So f of x is equal to this one. So we know the formula f dash of x is equal to limit h tends to 0 f of x plus h minus f of x upon h. Okay, so expanding we get f dash of x is equal to limit h tends to 0. Now adding h to all the x variables, so we get x plus h minus 1. Okay, and here x plus h minus 2. Okay, adding h to all the x variables and minus this part is finished. Now f of x, the function as it is. Okay, x minus 1 into x minus 2. Okay, it will be like this upon h. Now let's multiply this. Okay, so limit h tends to 0, x into x into x is equal to x square, x into h is equal to plus xh, x into minus 2 is minus 2x. Now h into x is equal to plus xh, h into h will be plus h square, h into minus 2 will be minus 2h. Now minus 1 into x will be minus x, minus 1 into h will be minus h, minus 1 into minus 2 will be plus 2. Okay, this set is complete. Now this one minus x into x will be x square, x into minus 2x, x into 2 will be minus 2x, minus 1 into x will be minus x, minus 1 into 2 will be plus 2. Okay, whole upon h. Now limit h tends to 0. Now if you see, okay, this is x square, xh and xh will be 2xh. Okay, 2x. Okay, this both are xh. Now 2x and x will be added, so minus 3x. Okay, minus 2x plus x plus minus x will be minus 3x. And okay, then after that plus h square, then after that you have 2h minus 2h and minus h, that will be minus 3h. Okay, and plus 2, that's it. Okay, now this negative will be multiplied inside, so it become minus x square plus, and this will become 3x. Okay, minus 2x minus 3x will become 3x, so minus 3x, this will be minus 3x, so it become positive 3x, and minus and plus will be minus 2. Okay, whole upon h. Now if you see, this positive x square and this negative x square will be cancelled. What is this? H square, yeah, h square. And minus 3x and positive 3x, negative 3x and positive 3x will be gone, and h square, positive 2 and negative 2 will be gone. Okay, now the remaining limit h tends to 0, so 2xh plus h square minus 3h. Okay, everything finished upon h. Okay, now let's take h common in the numerator side. Okay, it will be limit h tends to 0, h common, so here it will be 2x plus h minus 3. Okay, upon h. So this h and h get cancelled. You'll be having limit h tends to 0, 2x plus h minus 3. Now putting the value of x in the function, you have 2x plus 0 minus 3. which is 2x minus 3. Okay, so this is the answer. Okay, now we will do the same problem using power rule method also. Okay, power rule method, that is dy dx of x raised to n equal to n x raised to n minus 1. Okay, this is the formula. So f of x is equal to x minus 1 and x minus 2. Okay, so d by dx of f of x is equal to d by dx of x minus 1 and x minus 2. Now you see you have two functions, multiplication of two functions. Okay, so we can use either the product rule, derivative of the product rule, product of two functions, derivative of product of two functions, that is derivative of the first and d by dx of that is a d by dx of f of x multiplied by g of x. Okay, product of two functions, f of x and g of x. So derivative of f of x multiplied by g of x plus f of x and derivative of second function g of x. Now this is such big in size, so we'll use the UV. Okay, UV format. Okay, assuming the first function to be u and the second function to be v. Okay, just to make this shorter, that is if it's x minus 1 and x minus 2, it's two functions, so the first this can be assumed as u and this can be assumed as v. So u dot v or u multiplied v whole dash, this dash indicates this is another notation of derivative. Okay, d by dx. So uv whole dash is equal to same thing, same expansion, how this is expanded in the same way we expand this, only using dash, u dash v plus u v dash. Okay, same thing, derivative functions, first function then multiply with second function plus first function and the derivative of the second function, same thing, derivative of the first function multiplied with the second function plus first function and derivative of the second function, same thing. Okay, only thing is this looks a little smaller and visible. Okay, that's why we're using this. So now let's expand this on uv, assuming this to be uv, let's expand this in this form. Okay, so this will be f dash of x will be x minus 1 whole dash, or d by dx also you can write, but this is better, x minus 1 whole dash and b as it is x minus 2 second function plus x minus 1 as it is u and v dash x minus 2 whole dash. Okay, now now u is equal to x minus 1, so u dash will be how much, d by dx of x minus 1. Okay, that is when you split it, d by dx of x minus d by dx of 1. d by d of x is 1 and d by dx of derivative of 1 is 0. Okay, which will be 1. So u dash is equal to 1. Now v is equal to x minus 2, so v dash will be, implies v dash is equal to d by dx of x minus 2. Okay, d by dx of this one, which will be d by dx of x minus d by dx of derivative of 2. Okay, so again derivative of x will be 1 minus derivative of 2 will be 0, which is equal to 1. So v dash also we have 1. Now if we put these values u dash and v dash here, so u dash is 1, v is x minus 2 plus u is x minus 1 and v dash is 1. So this is equal to x minus 2 plus x minus 1. Okay, because both are multiplied 1. Now you see x minus 2 multiplied 1 is x minus 2, x minus 2 multiplied 1 is x minus 1. So we add this both, see x minus 2 and x minus 1, you get 2x minus 3. Okay, so 2x minus 3 is the answer. So we got the same answer by the first principle method and power rule method. Okay, that's it.